Hello everyone. Machine learning observability is an important part of your machine learning pipeline. Machine learning observability mostly come into the MLOps section of your machine learning pipeline, where the DevOps engineer or the MLOps engineer or the IT people, they try to run these machine learning experiments and track whatever information needs to be tracked. However, the MLOps is not limited to that. MLOps can be used by the data scientist, AI engineer, ML engineers as well, where they could run these experiments again and again and validate their machine learning model performance so that they can assure that the models are being built for the business requirement and they are also optimized to use the resources perfectly as available within their runtime environment. So if you are data scientist, a machine learning engineer, or an AI engineer, or the DevOps or the MLOps engineer, where your objective is to learn more about machine learning experimentations, models, and you are responsible to managing your machine learning models, this tutorial is going to be very important for you. Hello everyone, my name is Avkash, and in this tutorial, I will take you to the Neptune.ai Machine Learning Observability Platform test drive, where we are going to look how the Neptune.ai platform can be used for machine learning, experiment tracking, and machine learning model registry, and other functionalities related with MLOps. So let's get started. The Neptune.ai is the machine learning observability platform. It means when you are running machine learning experiments wherever you are, whether it's on-prem, anywhere in cloud, or whatever runtime you have, and you would want to first observe your machine learning process, and you want to save all the statistics, including metadata, your code, and all the metrics and everything with regard to your machine learning experiment. You want a platform which can store all that data. So if you are running multiple of these experiments, your objective is to access those multiple experiments, compare them, validate whatever you need to do, and you have an opportunity to export your model depending on which particular run or training run is the one you want to select for your final model. So machine learning observability platforms are very important for any enterprise if they are using machine learning for their businesses, and several other startups and organizations are building these machine learning observability platform. Today, we are giving a test drive for the Neptune.ai machine learning observability platform. It's designed for enterprise teams where you have your machine learning experiment tracking as long as you are using one of the supported runtime environment as provided by Neptune.ai, and it also provides you the machine learning model registry. Neptune.ai is a cloud service, and it is, as you could see here, it is used by a variety of organizations. You can understand that there are three things they are trying to use in their platform. First, the metadata related with your runtime experiment or machine learning runtime experiment first. Second, the machine learning model itself. So it means that it has the model registry where you could upload all those models and use depending on where your needs are. And third, an immersive experience for enterprise to work together in a single platform where variety of engineers, whether they are ML engineers or MLOps engineers or the data scientists, they all can work together and explore what has been done with the machine learning pipeline and extract the information, what each one, depending on what their roles are, and get most out of it. So those three things are covered in the Neptune.ai platform. and it's a service. So if you are using Neptune service and if there is some issues, you can always visit to status.neptune.ai and you are going to get current running status regarding their cloud service. Because the way Neptune AI SaaS service work is that wherever you are running your experiments, you are uploading all the metrics and all the run related data to the Neptune servers, and you are accessing the Neptune dashboard to visualize all that information. So it's a very common way to provide the machine learning monitoring or machine learning observability. So Neptune is also doing exactly the same. If you are new to machine learning, or if you are just starting your journey in machine learning, if you would want to learn the detailed information about the machine learning lifecycle, I would request you to please visit one of this video which I have created for you, and you are going to learn a good amount of information with regard to a machine learning lifecycle in all of these 4 steps as shown here in this image. Very recently, I have also reviewed a couple of other great products which provide machine learning observability as well. Very recently, I was using the Comet ML and I have reviewed their machine learning model registry, and that you could see here. And I also worked on machine learning observability or machine learning tracking. So these 2 tutorials are also going to be very useful for you. So please visit and try to understand that what other machine learning observability platform provide while you are looking into Neptune.ai or Comet ML. DataRobot is not new in this machine learning space. They have been here for several years. And while I was in H2O.ai, I had opportunity to work with several engineers at DataRobot. So I have very good understanding of their platform, and I have used that in my several projects. So I have also created this video which shows the model deployment and the model management in the DataRobot AI cloud platform. A great detail of information you are going to learn while using the platform like DataRobot AI cloud. So that is another great tutorial for you to really review, and combining all this information is going to give you in-depth information about what a machine learning operations pipeline or MLOps pipeline should look like, and what kind of functionality it should have, what makes a best machine learning ops pipeline. So all that information is available for you. So please review as your convenience. And now we will start our tutorial related with Neptune.ai. Before you could use the Neptune.ai observability platform, please sign up yourself. Once you have your account ready with Neptune.ai, you will have opportunity to access their application platform or observability platform with this URL. And as you could see that I do have access to that platform. If you are interested to look into variety of examples related with Neptune.ai, please visit their GitHub repo and you are going to get lots of examples needed for your requirement. For this tutorial, I will be using the Jupyter notebooks or the Python notebooks which are available at my Google Colab. I already have these 2 notebooks available at my Colab, and these 2 notebooks are going to be available in my public code repo, which is publicly available, and I will be syncing these 2 Jupyter notebooks to my public code repo. So anybody who would want to take advantage of this tutorial can work on those Jupyter notebook. So this first Jupyter notebook is just a base notebook. It does not have any integration with the Neptune AI. And the second one is the same notebook which does exactly the same machine learning operation. However, This Jupyter Notebook has the code related with Neptune.ai integrated in it. It means when we are going to run the experiment in the second selected notebook, all the experiment details will be available at this Neptune AI monitoring server. So let's open this very first Jupyter Notebook. This very first Jupyter Notebook is related with a heart disease detection machine learning experiment using the Keras as the machine learning library, and underneath it is using the TensorFlow. I have a detailed tutorial available for this Jupyter Notebook, and that tutorial is available here. And I have went in depth to show how you could run the machine learning experiment in Keras with monitoring and without monitoring. So exploratory data analysis, network visualization, looking into the metrics, tracking the machine learning process, and variety of plots. All that thing is available in this Jupyter Notebook. So if your interest is to learn a lot about the experiment we have in this tutorial, my request would be to please visit this section and go through with this tutorial. And because I have already completed this tutorial, I will not be going to a lot deep in this tutorial, and my objective will be to just first show you what is there without even going to explain in each step what is going on. And then I will jump to the second Jupyter Notebook where I will show you how to use an experiment like this, which is using the Keras and TensorFlow as machine learning library, and how to integrate the machine learning monitoring using Neptune.ai. So very first, this is a very popular and publicly available the heart disease data set. The features are already explained here. And very first, we will look into the files available in this server, because I am running this Jupyter Notebook at Google Colab and there is no CSV file here. So we need to upload the CSV file in this Google Colab. So we could use that as our source data. I will run it and it will give me an opportunity to select the CSV file, heart.csv, which I have downloaded on my local machine, and I'm uploading it. If you want that heart disease, you can actually get and from these locations. Now, the heart.csv is available at the Google Colab server. It means I could use it. I'm importing the pandas and various matplotlib related libraries, importing the data set. This is our data set right now. It's 303 rows and 14 columns. Here is the list of columns we have. And if you look into this target, so target column is our target column. It means that it has the value of 0 and 1. 1 means this particular record or this particular entity shows that this person has the heart disease versus this one does not. So depending on these feature values in any given row, whether this person is going to have the heart disease or not. So next step for us is to split this data in a way so that we can get all the columns minus the target columns. So here, very first, before we go a little more deeper to extract the column, target column and the remaining features, we are just doing some exploratory data analysis. So here we are looking into the distribution between the heart disease having or not heart disease having among all 303 row. Here is the distribution of having heart disease among the gender, male or female, for having or not having. Here is the heat map to show the correlation using Pearson, and that shows that which features are highly correlated versus which features are not. So that's EDA, just a very little EDA to refresh you that you also have to learn about EDA while you are doing any machine learning experimentation. Now we are splitting the data set. So one will become the DF input and one became the DF target. So one column and for 303 rows in your target column, and 13 columns and 303 rows in your sourced input. So now you have source and target, two separate data frames. In the next step, we need to convert our input data set in a way that it can be transformed and it could become ready for our deep learning process using Keras and TensorFlow. So here we are performing the transformation, and now our data set is became transformed in a way that it's ready for machine learning. In the next step, we are going to take this input data set and split it into training and testing. And we are using this 30% split here. So 70% of the data will be in training and 30% data will be in testing. And that what you could see here in this training and testing data frames. Okay. Now we are importing the Keras.models and Keras.layers so that we could create a sequential model with the dense layers. And here's the thought process behind this model definition or network definition related with Keras. So we are going to import these and then we are going to define our model. Again, I'm really not going deep because I already have a separate tutorial. So please bear with me. At this point, our network is decided, and here you could see that these are the three different layers. 13 input DIMMs, so 13 input features are coming and one output at the last, because that's what where output will be. Now we are just looking into our model definition, that how we have defined our network model. And here, if we would want to perform the tracking, we could perform the tracking related with our machine learning experiment. And here, this particular plot loss is used as a callback. And why we are seeing here this method is that when you are going to use the Neptune.ai or any other third-party machine learning monitoring platform, you are going to set up a callback, because the callback is which takes this model.fit or the machine learning training process and start exporting data wherever you would want to hook them. And in this scenario, we are just hooking these metrics to a local graph. And that's what we are doing here. So model.compile using the optimizer as a Adam, and our metrics is accuracy here with the loss defined as a binary cross entropy. I will start this experiment, and as you could see here, the experiment is started, and very quickly that loss graph is available for us. And in this training, we are not using the validation data. That's why the validation graph is not visible here. So we ran about 100 epochs, and those epochs are completed. So out of 100 epochs, the training data metrics loss is started from here and it reduced all the way up to here. If we would want to plot different way, here is another method to use this plot learning, and you could see the accuracy and the loss together in the same graph. So we have learned how you could run the experimentation. So here is like if you would want to see the two graphs. So let me just complete it. It's just going to take a few seconds. And here you could see that there are two different graphs are available to show the accuracy and the loss. So in this experiment, I'm not using the validation right now. It's just using the training data. However, it is about about 80 epochs. So if you are interested into the learning how to perform the machine learning training with the validation data, you could use this Jupyter Notebook, and that is also available in my public repo. And that also shows in that Keras tutorial, which I have informed you earlier. So you learn that this is how you could see the metrics, and now we could understand the metrics related with our model. Our model accuracy is 82%. Here is the model history, because what we have done, we have stored this training results into this history object. So we could explore the history. It has the keys. We can look into the accuracy. Here you could see the graph between loss and accuracy. here is another way to plot the accuracy. So there are two separate ways you could plot. And finally, if you would want to see the confusion matrix, or if you would want to perform the model accuracy, and here you could use it. So very quick, you learn that how you could use the Keras as a machine learning engine to perform the heart disease detection experiment. And everything was happening in the local runtime. The next step is that we need to look the same experiment and use it with Neptune AI. So what I will do, I will take this and I will export this to my GitHub. So as you could see here, public code machine learning, there is no Neptune AI folder created. So when I will export it, it will be exported here. And I do have another tutorial which help you learn how you could connect your Google Colab with your GitHub account. So if you could set that thing up, it means that all these Google Colab notebook, you can always save them on a GitHub repo. I will select file, save a copy in GitHub. My repo is already connected. So I will select this public code, and in public code, the folder is machine_learning, and then I will create a new folder, Neptune AI. So I will select machine learning _ Neptune AI this way. So it's going to store the data in public code, these two folders, and I will say, please go ahead, creating a copy, and machine learning Neptune AI, and in machine learning folder created Neptune AI, and here is our Jupyter Notebook. Close it. If I will reload it here, and Neptune AI, I will keep it. So we have looked into this notebook. I will close it. I will open the second Jupyter Notebook now. So at this point, we are going to start our real experiment tutorial related with the Neptune AI machine learning monitoring platform. So this Jupyter Notebook already has all the commands available, so I could show this thing faster to you. So same experiment. Very first thing, you need to make sure that you do have the Neptune client installed in your local machine. If you do not have, make sure you install it. And as you could see here in this machine, I do have the Neptune client installed. If not, then you need to install. So while we are here, we need to look into our Neptune platform. And start creating a new project. So I will be creating a new project called Heart is Keras, or we can say Keras Heart Disease, KHD. And color, we can use light blue. It's a private, and we can. So this is a project we have created. Project create, and as soon as you create the project, this project is selected here. And as you could see here, most of the information doesn't exist, and here is the information given to us that please use the account name and the project name and this API token to integrate with your run. So wherever you are running your machine learning experiment, you have to initialize this Neptune runtime using the Neptune client object, and then use this Neptune run object wherever you are required to push the data related with your experiment. So that's kind of conceptually everybody does, and the supported frameworks are here. So most of the places where you are using the Neptune runtime, any framework means commonly it's going to use this way, and some of the framework there are already details available. So for example, if you are using TensorFlow, Keras, here is the way, scikit-learn, XGBoost, FastAI, Optuna, and other frameworks. So here is the TensorFlow, because we are using the TensorFlow. So here is an example shows how you could do for the TensorFlow. And for TensorFlow, you need to have this library installed, Neptune TensorFlow Keras. For that reason, in our experiment, I have also made sure that you do have that library installed. So here, we already checked the Neptune client. We will make sure that the Neptune TensorFlow Keras is also available in our runtime. So we do have these two libraries needed. Now we are going to import the Neptune library as well as the Neptune callback function, which we need to sync all the metrics and data related with our experiment to the Neptune server. So after we have imported the Neptune runtime as well as the Neptune callback related with the Keras integration of Neptune, now we need to initialize the Neptune. And because this code is related with one of my previous experiments, so I had to make sure that my project type API tokens are all correct as defined here. So my project is actually the Keras heart disease. So I need to make sure that is exactly defined as suggested. So that's my project. So we have updated the project. The API token start from EY and end with FQ, and EY ends with FQ. So our API token is right. So as of now, if you look into the experiment, there is no experiment, everything is 0. So as soon I will initialize this Neptune run object. So we have initialized the Neptune run object. Now wherever we want to push the metrics from our runtime, we will be using this Neptune run object. Next, we are going to initialize the Neptune model. So here is the heart disease prediction model for this experiment. So we have created the Neptune model and Neptune run is initialized, Neptune model is initialized. We can look into here, and as you could see here, there is a model initialized KHD mod, and that is for this experiment. So our experiment key was KHD, Keras heart disease. So for this key mod, so model, so Neptune run dash mod. So this model definition is decided, but there is no information about run yet because we haven't done anything related with the Neptune run object. Here is the model, but there is no details about model here because we haven't pushed any data yet. In the next step, we are going to set up the model version. We need to get the exact same model version what we have decided here. So it is KHD-MOD. So let's change this to KHD-MOD. So this model version relate with this model. So we have set it up the model version now. Let's come back here. We can look into the model, and as you see here that KHD mod 1 is added. So we have initialized the model and added the modded version, model version, and here is our runtime object which we haven't used yet. So setup related with our experiment for the Neptune model machine learning observability platform is ready now. We will look into the files available in this runtime. So heart.csv is already available. It means we could start performing the training. With regard to our experiment, first we have to load the data set, everything. So I'm loading the data set, and I will bypass all these steps without explaining anything to you because we have already explained those in previous examples here. So at this point, we have our training data ready. Now we are building our model definition. So importing the Keras, and here is the model network definition, and here is our model details. Here comes the very first step. We are defining the parameters related with our training. So here is the learning rate, momentum, epochs, let's keep it 100, and the batch size is 64 to start with. And this is your Neptune runtime object. So you are setting the parameters these. So these parameters will be stored in this Neptune run object. Now we are creating the optimizer which will be used for our Keras model. So our optimizer is Adam, and it's going to use the learning rate as this defined here. So we have our optimizer. Oh, sorry. Let me import TensorFlow, and here is our optimizer ready. Now we are setting up the Neptune callback, and this Neptune callback is calling this Neptune callback method, and it's using this Neptune runtime object with the base namespace for the training. So our Neptune callback is initialized. Now for every epoch, we are trying to upload the training, loss, and F1 score, all those values to the Neptune server from our training runtime. And if we come back, look into here, our run, as you could see here, none of the information is pushed here yet. So we are setting up this Neptune runtime object and adding parameters. So we have added parameters, then we have added these training loss values. Keep an eye, run is still here. Next, we are going to compile our model. So model.compile using optimizer, which is optimizer. Loss is set to binary cross entropy, and metrics we are using the accuracy. So it's the accuracy with loss. So these two metrics will be used for our model. And now we are trying to start the training with model.fit. Here is our training data. Here is our target data. So train and target. Epochs are coming out from this param. So it's going to be 100 epochs. Batch size is a 64. It's coming here. Callback is this callback, which we have defined. And this callback is Neptune callback. It means when this is going to start, the callbacks will be called, and the Neptune runtime underneath will pick it up and start pushing data from local runtime to the Neptune server. And verbose means, yeah, please write some of the details visible here while the experiment is going to run. At this point, nothing has happened at the Neptune server. Let's start it. And because of verbose, we are seeing these epochs very quickly. We can look into here. And as you could see here, the very first experiment, KHD1, is added. So KHD1 is the experiment which is listed here. And after this 100 epochs were completed, our training is done. Results are stored here. So I'm the owner who is running this experiment. This experiment is started here. We could click, and here is the metadata related with our experiment. Charts related with our experiment shows the training and loss, training for the and accuracy. Here is the loss. Here you could see the per epoch accuracy and per epoch loss. So loss is going this way and your accuracy is growing. It started from here and it's growing. Here is the monitoring graph. So this monitoring is the environment monitoring. It means where your experiment is running, what is the CPU metrics, and here is the memory for that experiment, and here is the output. So 100 epochs output, log related with your, and source code. It means if you have your Jupyter notebooks or your Git or connectivity with your PI files, anything can be pushed into. So Neptune.init, and here you could select the number of source files related with your experiment. They will be pushed at the Neptune server. Artifact. You could push your training data. If you have tables and other files related with your experiment, all that thing can be updated. So artifact is total information related with your project itself, which is used to start the machine learning training. So variety of things you have done, you have seen very quickly, and that was your experiment number 1. Models. There is nothing about model. We have pushed here. However, if you could see here, some of that information related with model is being automatically added here. And I will come back to here and I will show you that the model related information is being added by this command, because when you have suggested for system to start pushing the training data per epoch, so the Neptune system is start understanding about the model, and here is your model ID, KHD mod, and you can look into some of this information related. But you see here that we do not have the size, etc., because we haven't really pushed the model at Neptune server yet. Let's look into the experiment. Here is the chart, and while you are looking into the experiment, there are 3 tabs: runs table, horizontal split, and compare runs. When you are selecting the experiment, you can select an experiment and you can see the details related with that experiment. But however, I haven't ran any other experiment, so the comparison is not available. We will perform another experiment, and this time we will use the learning rate. Just make it 10 and epochs are 200. So we have changed the parameters. Now parameters are changed, so we could run this experiment again. So we have started experiment with 200 epochs, change learning rate. Because we have started the second run with a different metrics, what is going to happen is that because our Neptune runtime object, which we have created here with this callback, and that callback is Neptune run, is not changed. So all the data related with this second level of training is going to be updated top of the very first experiment which we have done. And if you look into the monitoring, and as you could see here, now it shows the 200 epochs. For this training and chart will also going to show you that training. So you could see here that for the epochs, how this experimentation happened: time, absolute, and relative. So start to end versus the time. So you must understand that if you would want to create this new experiment, you would have to create the new Neptune runtime object. So in order to create the runtime object, you have to complete the runtime object first. So what we need to do is that we need to complete this runtime by calling this Neptune run.stop. So we have already ran another experiment, and here we could evaluate the metrics, and here is our metrics related with experiments are added here, metadata, and some of those metrics are added here because we have called this is the evaluation metrics. They are based on evaluation metrics, model.evaluate. We have used on test. I will not run this whole thing. Now we'll jump all the way here. And finally, we will call model version.stop and Neptune run.stop. Now we can look into the experiment. As you see here, this yellow icon shows that experiment is still running, but after some time that experiment will finally disconnected from here runtime environment to the server, and it will show that it stops. So now this experiment is stopped. So previously we have stopped the Neptune runtime to connect with the experiment server, so we could restart it. So I have same experiment is still running here, and I will come back to run because the Neptune run is stopped. So I will reinitialize it, and as you are going to reinitialize it, actually it's going to create the another run here. So after we initialize the Neptune run object, now we do have second experiment is added, HD3. We do not need to initialize the model again because the model is already been added. So KHD mod is already there. If we want, we can initialize this model version. So now we have Neptune run object available for us, and we have also initialized the model version KHD mod. If we look into server for the models, KHD mod 2 is available. So we have initialized the another version for this model. Come back here, we have Neptune run model version. Rest of the code we don't really need to run, because what we need is that we need to use this parameters if we want to change anything here. So we can say the epochs are 150 now, batch is 32, and these parameters will be stored in this Neptune run, which is the brand new object. Rest of the parameters are the same. Now we have to initialize the callback. So it's using the Neptune run object. So our callback store these parameters back to the Neptune run object. And here is the compile. So because our parameters are changed, I think compile, we can recompile it, and now we can run this experiment with 150 epochs. Run HD3 charts. As you could see here, this experiment number 2 is also available here. These are the evaluation metrics. So we are pushing those evaluation metrics also. We can save this model. And now here is the model version dot upload staging, and let's look into the. So as you could see here in the model version 2, now we have this model uploaded, and it's a model version 2. Size is very small model, and staging is active right now. So we have pushed the model, and if we would want to stop, we could stop the model version object. Same thing with Neptune run. But before we stop, we can come back here, go to runs, because now we have 2 runs, so we could do the comparison. We could select these 2, and we can come back here in the comparison chart. So there is 2, so we can create the chart related with comparison. So here we have these 2 selected, and if you see, if you would want to view them, you can enable this view and come back here, and here you could see the comparison related with these 2 runs in this view. Here you could have everything in a one view, one graph at a time, and this one has 2 run related with KHD1 and KHD3. In this experiment, we only have data. Actually, we have data related with. Oh, there is a one from here, one from here. It's a side by side. Here is. These are the all graphs related with KHD1 and KHD2. So 2 different runs. Here is another way to look into. So here you have experiment and the comparison also built into. So you have 3 different ways to look the information which is available here. So here is the split. You can look into, and you can go a little more deeper. So zoom built into the graphs, parallel coordinates. Let me see if the compare runs. In this mode, we could see this. So right now we have only 2 experiments. So KHD3 and KHD1. So if we have multiple of experiments, maybe 10 of them, then the value of parallel coordinates would be really very good to enjoy. Here is the parameter view just next to each other. Time, accuracy, how everything is being changed between KHD1 to KHD2. The CPU time is taken, and so system as well as the machine learning, all metrics are visible for you. So you can look into the loss version, accuracy, epochs. So here train for 200 versus 150, batch size. So learning rate 0.01 and 0.001. It means all those metrics are added into our experiment. Let's see. Row with difference only. Okay, so where the changes are up and down, so you could get this immediate analytical view to just glance and see, okay, what is happening. Images, we haven't updated any image, so if you would want to update any of these images, we could update here. So we will try to upload one image from our runtime to this KHD3 runtime here. So here we could check where the images are. So we can look into ls So we have model plot PNG image. Now we will try to upload it. So Neptune run data network plot, and it's going to upload this model plot PNG. And if we come back here, charts, images, and here's the network plot. So all the images related with your experiment, you can push from your local runtime environment to Neptune server. Come back here and we upload this model, and let's try to stop it. So we have stopped everything. Let's come back here, look into the models, model 2, sys. So here are the model parameters related with this model which we have just pushed. So it says staging active, and it should be stopped because this both experiments are stopped. First is already done, second we have just completed. Now let's try one more experiment very quickly. And at this point we already know that to start we will initialize the Neptune run object. We do not need to do this Neptune model because it's only done, init model is done only one time, very first time. So we are just updating the model version. So here we are going to update this model version. If we come back here, now we have experiment KHD5 is added. We can come back to the models, and here will be a new model. Model 3 is added. One more network layer. Let's have this 10. So our model changed. The image is also changed. And let's use 250. Batch size is 64. Optimizer is okay. And then we will define the callback with the newer Neptune run object. That is also compile, and we can run now. At this point, we can look into the run charts, and it's going to take a little longer to complete because it's a 250 epochs. So 250 epochs, evaluation metrics. If we want to look into the comparison, and comparison, just enable all view, first 5 side by side. So we have 3 experiment images. We have only 1, but now we can push the newer image. After that, we will download the model. Model is downloaded. We will update the model, and here we will call it production. So uploading the model, calling the production. So model type, we have productions. Okay, so production is already being updated, so not a problem. Now we can upload this image. We have uploaded this image. So just for experimentation, we could see that these 3 view all. These are the chart including all 3. And finally, we will stop the model version and stop the run. If you would want to push your Jupyter Notebook, what you need is that you need to have this Neptune Notebook installed, and you need to make sure that Neptune Notebook extension is enabled. And when Neptune Notebook extension is enabled, you can actually push these Jupyter Notebook directly from your Jupyter Notebook upload extension. And that is actually shown here, that once you have extension enabled, you have ability to upload this. Just click here and then the Jupyter Notebook will be uploaded. I was not able to enable that extension here in Google Colab yet, but I gave you idea how you could do it. Metadata, I am not really sending the content related with this project, but if I want to upload this Jupyter Notebook, I could. So this is a init project. So we need to initialize the project and we could upload it. So after we have completed our experiment, let's push this Jupyter Notebook to GitHub also, so everybody could access it. It's going to be public code, machine, Neptune, AI. Let's push. Now we have 2 Jupyter notebooks available here. So please feel free to visit this public code repo and get this Jupyter notebook for. So let's finalize our learning and recap what we have done. We started with these 2 Jupyter notebook. We learned our base code, which is using Keras and TensorFlow to create the binary classification for a person to have heart disease or not. Then we use the second Jupyter notebook and use the Neptune modules so that we could see the machine learning experimentation directly at the Neptune server. So we ran 3 different experiments. We learned how the metrics are being pushed from local runtime to the Neptune server. And we also pushed the models for each run. And finally, the version 2 and version 3, we pushed the model as a staging and production. And that's where we got all the information about our experiment, its model, its runtime. We also learned how we could compare these runtime in variety of ways as given by the Neptune monitoring server. So several things can be done with Neptune machine learning observability platform if you are running machine learning experiment. I'm sure you have enjoyed this tutorial where we used Neptune.ai machine learning observability platform to learn how we could track our machine learning experiments using Neptune.ai platform, and we can also manage our machine learning models combining with machine learning monitoring and tracking. So that's all I had for you in this tutorial. I am glad that I had you in this test trial, and I will be seeing you in my another tutorial. Until then, thank you. That's all, my friends. If you have enjoyed our content, please like it, share it, subscribe it. And finally, please remember, be good and do good. Thank you.